we've just seen that the lower estimate of the area under the curve corresponding to these trapezoids, or these intervals, is 0.64. That's the area from the red line down. The area from the green line down is 0.74. The difference, which corresponds to the areas of these little rectangles here, bounded below by the red line and above by the green line, the total area of all those is the difference between the lower and the upper estimate, which is 0.1, which again, if we look at how the calculation was done, if we subtract these numbers from these numbers, the last four numbers here and the first four numbers here cancel, and we end up with just 0.2 minus 0.1 or 0.1. So we see what that difference is. It's important to understand now that a trapezoidal estimate would actually be much more accurate than either the lower or the upper. The trapezoidal estimate, of course, averages the upper and the lower on each interval and will be equal to the average of the upper estimate and the lower estimate, or midway between the upper and the lower estimate. So let's store that idea away. We can also see that geometrically. The trapezoid splits the little rectangle that represents the difference between the lower and the upper estimate. Each segment of the trapezoid, upper segment, each sloping segment here, just is a diagonal of the rectangle that represents the error that we have, or the difference between the lower and the upper estimate. So that's kind of important and kind of significant. Now we want to look more generally at the situation, and we've already seen this, so we're going to go through this pretty quickly. But if we want the area under a curve between t values a and b, we can approximate that area by making a partition. By partitioning the curve with a t0 equals a, then a t1, a t2, and so on, up to some tn, which is equal to b. We think of using equal intervals, although that's not absolutely necessary. It makes the algebra a little simpler. And again, the altitudes are f of t0, f of t1, f of t2, and then we have a little break in the function here. Now we didn't put a break up here, but let's not be too picky about that. And then we have f of tn at this end, and moving back from the f of tn, we have f of tn minus 1 and f of tn minus 2, corresponding to the points tn minus 1 and tn minus 2. If this point is tn, then this must be tn minus 1, and then this must be tn minus 2. And there's an undetermined number of points in between. As we saw before, the lower and the upper estimates are going to be as indicated. The lower estimates, if this thing is increasing, are f of t0 delta t, the area of the first, based on the altitude, the lower altitude f of t0, and then based on the lower altitude f of t1 for the second rectangle, we use f of t1 times delta t and so forth, stopping with the lower estimate for the last rectangle, which is going to be f of tn minus 1, of course, times the delta t. And the upper estimates are, as we see, we start with f of t1, the upper estimate on the first interval, and we go to f of tn, the upper estimate on the last interval. Everything except the last term here and the first term here is going to be identical, so if we subtract the lower from the upper, those are all going to cancel out, and we're just going to end up with f of tn minus f of, well, let's say f of tn delta t minus f of t0 delta t, and of course we can factor out the common delta t, and we get f of tn minus f of t0 quantity times delta t. That's going to be the difference between the upper and the lower.